This is a continuation of our video about how to determine whether the argument is valid or not valid using the truth table. Okay, for our next example, this time the argument is already written in symbolic form. Okay, so we don't need to worry about the symbols we're going to use for its statement. Okay, we have here P implies R as your first premise, and your second premise is R. Then the conclusion is therefore P. Again, is this valid or not valid? To verify whether this is valid or not valid, we construct the truth table. P, then R. There are only two propositional variables. And then the first premise is P implies R. It's your first premise. Your second premise is R. And the conclusion is P. Okay, so first premise, your second premise, and your conclusion. Okay. The truth values here are true, 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 false, false, true, false, false. And then for our first premise, this is true, this is false, this is true, and this is true. Your second premise is R, so you have here R, so let's just copy that truth value. Okay, and then let's eliminate those rows for which at least one premise is false. So we eliminate this and we eliminate this. Then we have two remaining rows, no, which are called as critical rows. So again, what we're going to do is to determine the truth value of your conclusion at the critical rows. Okay, your conclusion is P. Okay, in this row, P is true, so you have true for P. Now in this row, your conclusion is P, and your P here is false, so this is false. Okay, again, we have a case where in the critical rows, the conclusion, one of the conclusions is false. So regardless of whether there's a row, critical row, where the conclusion is true, as long as there is one row or one critical row where your conclusion is false, that makes the argument to be invalid. So this argument is invalid. Okay. For our second example, we have first premise, R implies negation of G. Second premise is negation of R. And third premise is, it's not the third premise, it's the conclusion. Therefore, G. Again, to determine whether this is valid or not valid, we're going to construct the truth table. You have R and G. Then your first premise is R implies negation of G. Second premise is negation of R. And your conclusion is G. Okay. So first, second, and your conclusion. Again, we have true, 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 false, false, true, false, false. Now, R implies negation of G. Take note, negation of G here is true. So, maybe to facilitate our computation, let's to avoid confusion, they have true, true, false, false. Let's just copy this. Well, your negation of G here is false because this is true, this is true, this is false, and we have true. Okay, So R implies negation of G. This will become false, right? Okay. This is true, this is true, and this is true. Okay, so this is the truth table for our first premise. And your second premise is negation of R. Your R here is true, so this is false. This is false. This is true. This is true. Okay. And then we eliminate those rows where your where one of the premises is false. So we eliminate this because we have only two rows where your premises are true. So these are called as critical rows. And in those critical rows, we're going to determine the truth value of our conclusion. Your conclusion is G. Now G here is true, so therefore this is true, right? Or your G here is false, so therefore this is false. Again, we have a critical row where the conclusion is false. So this makes the argument to be invalid.